Right. For a couple of days, we were focusing on BGP attributes. Now, I would like to quickly remind that the attributes are classified into various categories, like well known. Example, next hop. So you cannot have any update for route to update for any destination without a next hop. The next hop address is the mandatory one, isn't it? Without next hop, can we have any route? Without knowing where to send, you cannot have a route, right? Yes. Okay. Hmm. Hmm. Zeroth attribute. Yeah. Yeah. Need to be. You should call it as attributes. Hmm. BGP attributes. Hmm. Yeah. Correct. Correct. See, why are we calling this as attribute? Actually, this is metric only, but when they have given a special name, we have to strictly follow that. If you say metric, it is uh, it is something less to BGP. You're supposed to tell attribute to mean that you know how BGP works. If you simply say metric, it is of course metric, but it is not giving the in-depth BGP's specialty. When you say attribute, then only it gives more emphasis on the special metric that BGP has got. So we call it as attributes. You see, when you say simply metric, it is like one another protocol. But when you say attribute, it is making BGP special. But nothing wrong in calling it as a metric. But when you call as an attribute, it suits better, much better than metric, distant metrics. Mhm. Let me draw what you say. Okay, let me draw what you say. We got three routers. Okay, this is triangle only. Router C, no connection, no physical connection. Hmm. Towards whom? Of course, there is only two router A. Okay, so we cannot say next up self to EBGP. It is only for IBGP. So you let's say the neighbor address is like this. So on B, on router B, you say neighbor 1.1.1.1 next hop self. Neighbor 3.3.3.3 next hop self. Likewise, you'll go to router C and say 1.1.1.1 and 2.2.2.2 as a neighbor. No BGP. You don't want to form neighbor from B to C. Is that you're saying? Okay. So it is not full mesh then. Hmm. Okay, okay, okay. In C, when you don't give next hop self, the only path that will be available to reach this, let's say 144 network, is via B. Let's say you have 144 network advertised from D. It will be advertised to A by two neighbors, but when router B advertises, it will say 144.4.0.0/16 is given by 2.2.2.2. That's the next hop. Whereas on router, the other neighbor, when router C gives it for the same network, it will be 4.4.4, whatever the neighbor address that you used. Router D's address. Router D's address. So unfortunately, router A don't have reachability. Why? Because we don't run OSPF up to here. We run OSPF only. Yeah. You are very correct, and C will not be considered. C route will be seen in the BGP table, but C route will not be used because of unreachable next hop, invalid next hop. According to EA, address of D is unreachable, invalid. Okay, so it will not further check the other attributes. The attributes will come into picture only when we have multiple paths. Whether to choose this or that, even metric, no, in OSPF or RIP or EIGRP, if you don't have multiple paths, will the metric be useful? No. Whether you like it or not, that's the only path you have. Though we saw like we have 0 to 39, 11 attributes, they're all of not same characteristics. Some attributes are known as well-known attributes. For example, I told you just now, next hop. You cannot see any update without a next hop. Even in OSP, in RIP, you will always have a next hop address. Without next hop address, the advertisement is useless. First of all, it won't be sent. So such attributes which are mandatory. Again, AS path. In BGP, without autonomous system number, you cannot have any advertisement. Whether it is Cisco router running BGP or any other vendor running BGP, everyone will definitely have this particular update in all their advertisement. Those updates are called as, those attributes are called as well-known attributes. Well-known means popular, isn't it? Well-known, popular attributes. Example, I have told two. Remember, you may need to answer this in the interview. Next hop, AS path, AS number. Without this, you will not find any advertisement. You see, AS path. Next hop, origin. See the first three with the star. They are always seen in every advertisement from any vendor device, whether it is Cisco or any vendor. If they run BGP, definitely those advertisements coming will have AS path, next hop, and origin. They are well known. In that well known, again there is two classification: mandatory, discretionary. Those three that you learned as well known, it is mandatory also. Meaning, I told you, without those updates, without those attributes, the update will be invalid. Which means what? It is not only well known, it is mandate. Next up is mandate. AS path is mandate. Origin is mandate. What is origin? How it is given to BGP. Did anyone advertise inside BGP or someone redistributed into BGP? How it is originated? That is also a mandatory, well-known mandatory attributes. But there are some attributes which are well-known but not mandatory. Even if it is not there, it is okay. Still, they are valid update. Such attributes are called as discretionary. Well-known, discretionary. You see, local preference. That is also well-known. You see, local preference is also well-known, but it is discretionary. What does that mean? Even if you don't configure this particular attribute, it is okay. It's still valid. Well-known, discretionary. Local preference. Now, what is local preference? Local preference is a numerical value that you set to a router. If you don't set, the default value is 100. If you'll set a higher value on one of the router, and when you got multiple exit, the router with the higher value will be preferred exit. The router with a higher local preference will be a preferred exit. Now, local preference that you configure on one router will be advertised to every router. See, on C router, you no need to say A is preferred. In C router, you no need to say A has got 200 local preference, go via A. You no need to say that. As soon as you configure a higher local preference on one of the exit router, every router will come to know about that in that autonomous system. Within this autonomous system, even if you have 50 routers, all the routers will try to go only via A, provided there is a tie-in this too. Only then the local preference attribute will come into picture. If someone has already set wait on one of the router, then local preference will not be preferred. So if there is tie in this first two attribute, definitely it will check the local preference, and the router with a high local preference will be preferred exit for every router in this autonomous system. So now going back to the attribute characteristics. We know what is well known now. We know what is mandatory, well known, mandatory. We also know what is well known, discretionary. Example for well known discretionary is local preference. The second attribute in the list. Number two. Number one is weight. Number two is local preference. Local preference is well known, discretionary. Next hop, the zeroth attribute is well known, mandatory. AS path, which is the fourth attribute, you see. AS path is the fourth attribute, which is also well known, mandatory. Origin, fifth attribute, well known, mandatory. This is also well known, mandatory. Another origin, local origin or coming from outside. And local preferences, well known, discretionary. Weight is an optional one. We'll come to that one later. Now, we have learned, the difference between well-known mandatory and well-known discretionary. I want you to read these lines and confirm whether you learned it correctly. Read yourself. Now let us move on to optional transitive, optional non-transitive. See, optional means you know, but here you need to say optional transitive and optional non-transitive. If this optional attribute is there, only then I will use it. Then it is called as optional non-transitive. If it is there, even though it is an optional attribute, I should see it. Otherwise, I will not accept it. Which means non-transitive if it is not there. Not transitive, non-transitive. I am not going to use it, I'm not going to give it to anyone. Even though it is an optional, I need it. So some vendors will be stubborn like that. Even though it's an optional, hey, we are very strict, you know. We want to see everything in place. Those vendors, that particular attribute which they say, we must see this, only then we will accept it. Otherwise, we won't accept, we won't process. That's our policy. Such attributes are called as optional non-transitive. What is optional transitive? Yeah, it is optional. If it is there, it's a complete update. If it is not there, still it is an update. We accept it as partial. We accept it as partial and use it. So it is called as optional transitive. Optional transitive means read. If not recognized, mark it as partial and you propagate to the neighbor. What is non-transitive? If not recognized, discard. Read to yourself. Is it clear? See why it is optional? It is not recognized by all BGP router, meaning some vendor may have it, some vendor may not have it. One such attribute is weight. This one is an optional attribute, but it is an optional transitive. Even if it is not there, it is okay. Even if it is not there, it is okay. Cisco will consider as okay. Accept it. Weight is a Cisco attribute. Will Juniper router send with this attribute? No. If Juniper router send the update, Cisco router will accept it and use it. Send it to others. Yeah. MED is optional and non-transitive. MED is optional only, but I should see some number. At least 0 I should see. Even 0, it is okay. If it is not there, I'm not going to transmit. Even though it is an optional, Cisco says I should see at least a 0 there. You see this output here. This is called MED. MED is mentioned as metric. That's why I don't want you to use the word metric for attributes. Because MED is called as the word metric. You see, the 0. At least that 0 should be there. Between EBGP, when it is sent, 0 should be there. Otherwise, it won't accept the EBGP update. For IBGP, it is okay. For EBGP, it is mandatory. So, optional non-transitive is MED. Don't forget some examples you should see for, you should say in the interview. Optional non-transitive is MED. Optional transitive in Cisco, weight. Well-known discretionary, local preference. Well-known mandatory, origin. You see, here it is written last line, you see. Well-known mandatory, origin. Next hop, well-known mandatory. AS path, well-known mandatory. Yeah. So these are the classifications. Now, I want to remind you again what we have learned on the previous class. Before that, I want to touch some attribute and what they are. Weight is local to the router. For example, you see you have only one router. You may have many routers in the inside. Now, on the edge, I have only one router. And I'm connected to two different ISPs, B and C. Because they are ISP, B is also giving me the path to reach Yahoo. C is also giving me the path to reach Yahoo. And I prefer to go via ISP B. So I will go and configure neighbor B, weight 200. So all the traffic will exit via this way. Only if this goes down, it will fall back to this one. It will fall to this one. Now, what is the difference between this and local preference? One is that is well known, discretionary. This is optional, transitive. Okay, this is optional, transitive. The other difference is this is only to that router, you see, only to the router on which you configure. Whereas local preference is you configure on one router, it is for the entire autonomous system. In one router, if you configure, in one router, if you configure, all the routers in the autonomous system will know it. Whereas weight is not like that. When you configure on one router, it is only for that router. See, it is within the AS. The local preference is sent to all IBGP neighbors within the, that is what within AS, IBGP means what? within the autonomous system. Now, one more thing you should know very strongly, you should tell in the interview, this one. BGP forwarding cable may have multiple paths for every destination. You may have multiple paths for each destination, but BGP is not. In Greek, if you say two times, which means this certainly. See how many times I say not. In English, you should not say like that. In Greek, if you say more than two times, it is very certain. BGP, I also want to make you to know very clearly, certainly, that BGP is not designed to perform load balancing. Even though you have multiple paths, don't expect BGP to load balance. Don't expect. Even if you have multiple paths, it will have one good reason to say why that only one path is chosen and other paths are ignored. This is how. Even if you have multiple paths, it is going to go through this one. At last it will say that neighbor has got lower neighbor ID. So that is the best path. Even if the router ID is same, not possible in the real world, even if it is same, it's going to say that neighbor has got lower IP address. So I'm going to go that way. So can the load balancing be possible? No, it's not possible. So this point you have to be very clear. They will ask you question. Can you do load balancing in BGP? Your answer should be, it is designed not to perform load balancing. But if you want to do load balancing, you have to do manually by writing route policy. That should be your answer. You should write route maps. You should write route maps to do that load balancing. I'm going to show you an example in a few minutes. But by default, by tuning attribute, can you achieve without route policy? No. Without writing a policy map, it is not possible. You have to manually do that load sharing by writing policy map. So, only one path will be taken, even if you have multiple paths. By eliminating, it will take only one single best path. That best path will be given to the routing table manager. See, it's not guaranteed that that route will be immediately installed into the routing table. It will give to the routing table manager. Routing table manager only will decide whether to keep this in the routing table or not. What routing table manager will do? It will see the administrative distance. If it is IBGP, the administrative distance is 200. Jana, what is the administrative distance in Cisco for IBGP? 200. For EBGP? Exactly. So let's say one neighbor is an IBGP neighbor, another neighbor is an EBGP neighbor. And both are giving same route. So this routing table manager will only choose this path. And this will not be taken because EBGP is preferred over IBGP. Look at this. Seventh attribute. Why? Because the administrative distance also matters. So before routing table decides, even the BGP table will also say, I prefer only EBGP. I prefer only lower administrative distance. But what if the competition is between the OSPF given route and IBGP given route? OSPF is only 110. IBGP is 200. Which one it is going to choose? OSPF. OSPF is 110. IBGP is 200. If the competition is between EBGP and OSPF, then it is going to be EBGP route. Is that understood? Why very silent? So silent. That is okay, no problem. Okay. We were talking about load sharing. If you want to do load balancing, you have to do manually. That is what we call it as policy-based load sharing. Using route map, we used to do. Look at this. To achieve this, we have to write route map. We need to do policy-based routing. From A to go to the internet via X or Y, this is the policy. 60% of bandwidth towards Y should be utilized, whereas towards X should be utilized, whereas towards Y only 20%. But the return traffic from X it is only 10%, from Y it should be 75%. These are all what? Your policy. You are doing some sort of manual load sharing. Yeah? So here, you see, this is a local preference command. If you are configuring local preference globally, if there is no load sharing, you just want to configure local preference, like we saw in the previous chapter. One router you said high value, all will go either. So it's not load sharing for all the routes. But if you want to do for some specific routes, for example, see this picture. For Y, this autonomous system will prefer to go this way. It won't take this path. Why? Because it is 1, 2, 3, 4 hops, 4 As. So for Y, all will go this way. 24 is Y. This is Y. Y. And then for 16, 1, 2 hop only. If you take this one, 1, 2, 3 hop. So for 16 or 16 network, all traffic will go via this way. This is default. This is by default load sharing. You are not doing manually. Because of the metric, they go in different paths. Not because of load sharing will come only when you have equal cost path. Same kind of attribute. So don't bring that here. Even if you have equal cost path, this type of iteration will happen and you take different path. You remember I told you next hop address is smaller, the router is smaller. Now, coming back to the discussion, for this 30 network, with that it will go exit via this way. So what do you understand from this? This is Z. This is X. For 16, it was going via X. Means it is exiting via A. For the rest two, it is exiting via B, or it is going to Y. Now let's see the percentage of traffic. This is Y, 2400. 30% of traffic is going down path. And then this is Z. This is also going via down path, 20%. This is 10%. So if you notice this diagram, only 10% of traffic is going via the upper path. Only 10% is going via upper path. In the below path only, 30 plus 20, 50% is going. In the below path, 50% is. Now you want to do load sharing. How you can do? I want to have equal load on both the paths. What I can do is, I can take 20 out of this so that this side will also be 30, and this side the 20 will be added, and that will also become 30%. You understand? Manual load sharing. You know? You understand what we are trying to do? Manually, we are doing load sharing by taking 50%, sorry, 20 from this 50, so that I can give the 20 to the upper one. Upper one already 10 is there, 10 plus 20 is 30. Now below one, after you deduct 20, you get again 30 only. So 30 that. How do we achieve that, you know? To identify the traffic, which is 20, 170 to 30. So write an access list for that. Call that under the route map and give high local preference and bind it to 28.1, which is here. Bind it to X. For this, you give high local preference and bind it to X, so that this 20 will go this way. Any router, if it wants to go to this network, it will start going this way. Yeah, the configuration is there. Configurations are not that important for your interview, but still you need to have this idea in your mind. In case if they keep this type of idea in their mind, ask you question, at least you will use that one word. We can write policy routing. We can write policy-based routing. You can write a route map to achieve this. That answer you should say. That's why I'm teaching. You need to go through this presentation that I have given you already. So